Okay, in this exercise or example, we're asked to graph a cubic function. Cubic meaning x cubed, x to the power of 3. And the simplest way to graph any function, if you don't know how to graph a particular function, the simplest way that never fails to graph any function is to make out a t-table to pick certain values of x and put those into the function and see what comes out. Make our points from there. So we're going to have a table of values. We're going to have x, and we'll have f of x, or y, which is equal to x cubed. And f of x is just y. Okay, so this is our y value. Okay, and it's a good idea to pick values of x that are close to the origin, usually. Depends on the particular question, but here we pick ones close to the origin, and pick integer values, so whole numbers. So minus 3, minus 2, minus 1, 0, 1, 2, 3. So all we're doing here is cubing the x. So it's going to be minus 3 cubed. Minus 3 cubed is minus 3 by minus 3. Minus by minus is plus, 3 by 3 is 9. So it's plus 9 by minus 3 again is minus 27. Okay. Do the same thing the whole way down. Minus 2 cubed. Minus 2 by minus 2 is 4. By minus 2 is minus 8. Minus 1 cubed is minus 1 by minus 1 is 1. By minus 1 is minus 1. 0 cubed. 0 by 0 by 0 is 0. 1 cubed is just going to be 1 by 1 by 1 is 1. 2 cubed. 2 by 2 by 2 is 8. And 3 cubed is going to be 27. Now, if you want to, you can add a third column and write out the points, turn these into points. And remember, when you're writing points, the x always comes first, so the x and the y. So minus 3, minus 27, minus 2, minus 8, minus 1, minus 1, 0, 0, 1, 1, 2, 8, and finally 327. Okay, so what I'm going to do now is I'm going to import some graph paper, and I've already prepared this. Let's see if it works. Oops, that's not right. So let me delete that and go back here for a second. Here's the graph that I'm going to use. Sorry about this. I thought this was already prepared for me. We'll go back here and try again. And there you go. Now, so this is our graph paper. And if you look, I've already put a scale on it. The x-axis is scaled in steps of 1, but the y-axis is scaled in steps of 5. So, the first point, negative 3, negative 27. So go over to 3 and down to roughly negative 27. Now 27 is going to be slightly less than halfway between negative 25 and negative 30. A little bit closer to the negative 25. So about there. And all we can do is our best at this point. All we can do is estimate the values. Now negative 2, negative 8. Over to negative 2, down to negative 8 is a little bit closer to 10. Or negative 10. Negative 1, negative 1. Over to negative 1, down to negative 1, which is very close to the x-axis on this particular scale. 0, 0, which is here. Okay. 1, 1. So over to 1 and up to 1, which is just again above the x-axis. 2, 8. Let's get this over a little bit so that I don't disturb anything else. So 2, 8, and 327, over to 3 and up to 27. Okay. So what this looks like, if we were to draw it, when you use a nice smooth curve, it goes up, and it's increasing all the way, and just at that single point through the origin, it becomes horizontal, just at a single point, and then it starts to climb again. And that's the shape of the x cubed graph. Now, if we go back over here for one moment, we'll just draw in the shape of that graph so that you can see what it looks like. X to the power of 3. We'll just make it thick so you can see that too. And there is the shape of the x cubed graph. So very similar to what we have. Okay, and we'll actually copy and paste this over as well. And if we just scroll on down here. Now our task was to draw it by hand, so this version, but it's always nice to be able to compare it to the version that's produced by a calculator or by a computer, and you can see that they're very, very similar. Okay, so that is the typical graph of x cubed, the one on the screen right now with the blue line. That's the graph of x cubed. It's one that you have to become familiar with, just as familiar as the other graphs you've seen, straight lines, parabolas, the graph of square root of x, log x, e to the x. All of these graphs, including this one, are graphs that have to be well known. Okay, thanks for watching.